Okay, hi guys. So in the previous lecture, we saw on the definition of aldol condensation, and we also saw the how the aldol is formed by reacting 2 moles of aldehyde or ketone with dilute NaOH. Okay, so I'll just write the reaction once more. So we had, let's suppose, aldehyde, and we reacted this aldehyde in dilute NaOH. Okay, so what product did we get? We got something like this, CH2 C double bond OH. Okay, so now what will happen is, again, when we already have the basic medium. When we heat this reaction mixture, then what actually happens is, this is aldol. So what actually happens is, this OH minus attacks on this carbon atom, the hydrogen atom. Okay, as a result, this carbon atom will get a negative charge here. Okay, and we get CH negative here, double bond OH. This will form a double bond with this carbon atom, and as a result, OH minus would be getting cleaved from the compound. So finally we get this as the product. Okay, so as this reaction took place, this is called aldol condensation. The complete reaction is called aldol condensation. Okay, so now let's get started with seeing some more examples on the same. So we have something like this compound on reacting with OH minus, we'll get something like OH here. Okay, so you have to just keep in mind that the ketone is actually less reactive towards the condensation. Okay, and we get only 2% product formed in this case. Aldehyde is actually more reactive towards aldol condensation. Okay, why it is more reactive? Because if you see the structure of a ketone and aldehyde, what you will get to know is, this carbon atom is more partial positively charged than this carbon atom. Why? Because it is already having 2 plus I groups or plus H groups attached to itself. Hence the reactivity towards aldol condensation would be higher for aldehyde. Okay, let's see another example. Herein we have pH C double bond O CH3, and we are reacting it again in basic medium, and we are also providing some heat. So what will happen in this case is, obviously 2 molecules or 2 mole or 2 compounds will come in contact with each other. What will happen is, obviously CH2, the OH minus will extract one of the hydrogen atom from this carbon atom. As a result, we'll be getting something like CH2 minus, and then this CH2 minus will be attacking this partially positively charged carbon atom, and as a result, OH minus will be taking away its electrons or bond electron from the carbon atom. Hence we'll get something like PHC double bond O CH2 C O negative, which on passing acidic medium will get to OH pH and CH3. Next, if we are heating this, what will we be getting? We'll be getting something like this hydrogen and this OH will be getting removed. As a result, we'll be forming a double bond here. So finally we'll be getting some elimination here, and this will be the final product formed. Okay, let's see another example. So we have something like this compound. Okay, again we are providing just basic medium, we are not heating it, hence the formation of aldol will take place. Aldol condensation will not take place. Okay, so what will happen again here is, it will attack on this carbon atom. As a result, we'll be getting something like double bond here, negative charge here. This will again be attacking on the ketone, and we'll be getting something like this compound. Okay, with OH here. Again, I'm providing acidic medium. This would be the final product. Okay, let's discuss one more example. So we have CH3, CH2, CH double bond O aldehyde. Again, when we are reacting it in acid basic medium and we are providing some heat also, what will happen in this cases? We will definitely be getting a negative charge at this carbon atom, okay, and CHO here. And as you know that aldehydes are very much reactive towards aldol condensation part and towards the aldol reaction in general. Why? Because this nucleophile has found a very good electrophile at this carbon, at this carbon's position, hence it will be attacking on this carbon, and as a result we'll be getting something like CH3 CH CHO here and single bond CH OH. Let's assume we are also passing H plus, so that this O minus gets converted into OH, okay. So I wrote it directly CH, and we have CH2 and CH3 here. Next, when we are heating, what will happen is this alpha hydrogen on related to this carbon atom and the OH on this carbon atom will dehydrate the compound by leaving as a H2O, and finally we'll be getting something like CHO here, okay, double bond C H CH2 CH3. This will be the final product which we'll be getting, okay. So let's actually take one more example before going on to our next topic, okay. So suppose we have something like CH3 double bond O CH3, and in basic medium we are heating it. So again, what will happen is, although it will be the yield will be less, but still it will actually react. So in this case we will be having that this CH3 minus, this CH3 will be getting attacked with OH minus, and as a result we'll be getting CH2 minus here. This CH2 minus will be again attacking on the keto group or the ketone group, and then we'll be getting something like CH3 C double bond O CH2 and CH. We are passing acidic medium as well, CH3 and CH3. Next, when we are passing or we are heating this compound, what will happen here is this H and OH would eliminate, and as a result dehydration of the compound will take place, and as a result we'll be getting something like double bond formed between these two carbon atoms and CH3 and CH3 attached. Will it be a single compound formed? Yes. Why? Because it won't be showing any geometrical isomerism, because two similar groups are attached on the same carbon atom, okay. So this is just a short trick for getting to the directly to the product of aldol. So rather aldol condensation. Short trick for aldol condensation is, you have something like let's suppose you have this compound, okay, two hydrogens were there here, okay, and when you are just passing it with OH minus medium and you are heating it, what you can imagine in mind is there is one more keto group, okay. Just remove the water molecule from these two compounds, and whatever compound you get after the removal, you just name it the aldol condensation, okay. So this will be the product formed, okay. So with this we come to an end of this lecture. In the next lecture we'll be seeing cross aldol condensation, and then we'll be seeing some more important topics. So till then, good luck and goodbye.